The brain is an organ, as I said, and it's made of cells, just like every other organ in your body. And there's lots and lots of cells in there. And we have a small understanding of what the single cells are doing, all right? You think maybe we understand really well what the cells do, but in fact we don't, all right, at the single cell level. And of course there's billions of these cells and they're connected in networks, all right? And there's billions and billions of connections in your brain. Now, we have a better understanding of single connections, how they operate, but we really don't understand together as a network how all this operates. And I often think about, let's compare it to physics, all right? So physics, which has moved so far ahead now, and really think back to the time of Plato, when they were thinking about atoms and the building blocks of matter. And neuroscience, I guess loosely speaking, is pretty much where physics was at the time of Plato. So we're just scratching the surface. And we're now in the phase where things are moving very fast and we are starting to get more and more information. And the next decade to 50 years is where we're going to get a better and better understanding of what's going in there and have a much better understanding of how it operates. And that's the next coming century, really. So it's very little, we know very little about what goes. We understand quite a bit about what happens in small animals like worms. Not a lot, despite the fact that these small bugs often only have hundreds of cells, and we have a fair idea what these cells do. You would think you'd be able to predict where a worm is going to be, 5 minutes from now, once you understood the resting state. But in fact, we don't, all right? And that's because we don't really understand how the system operates, all right? Of course, robots that we build ourselves, think about the rovers that got sent to Mars. The people in NASA could tell you within a centimeter where this machine is going to be 2 hours or 2 days from now, right? Very different to our understanding of biological systems. We have some vague ideas the way it's set up. And what's very clear that we talked about these neurons, the cells that make up the brain. They're not all one sort. There's dozens of different types of neurons, all right? They have a different morphology, they look different, they make different types of connections. Their extent, if you like, is quite different, some being very long. If you think about the cells that drive your movement, so there's cells which are up to 1 meter long, which go from your spinal cord all the way down to the bottom of your big toes. And there's other neurons which are very small, right? So there's this diversity of neurons. Now these cells are connected in networks. That is, they connect to each other. But on average, a single cell will make about 10,000 connections. So you can imagine how many connections there are. Now, these connected networks are put together into ensembles, if you like. And you think about the visual system versus the somatosensory system versus the auditory system. So there's those parts of it. And then there are systems that are wider than that as well. So there's systems that dominate attention, memory. And the nodes of this system, there's bits of the brain which are loosely speaking given as centers, if you like. And if you look, there's atlases of the brain. And if you look up an atlas of the brain, you'll see it's divided into regions. And the oldest one is the Brodmann Atlas, that's for a human. And the Brodmann Atlas has many, many different areas. And the human brain has over 1,000 different areas, all right? And these different areas are connected into ensembles, which then function to produce different outcomes. Sleep, dreaming, movement, hearing, analysis of voice, analysis of vision. So these networks all work together. Now, of course, this area all works simultaneously just about, right? If you think about you walking down the street, the image on your retina with the visual image and the hearing the sounds that you hear and the feeling of your toes and the wind, this is all seamlessly integrated. And of course, when you walk down the street, you don't get like 10 different experiences, right? You have one holistic experience of you walking down the street. It's not the case of, I can feel this on my legs, and I can see a relief there. And of course, somebody asks you a question, you can describe that. But this is the parallel processing that's going on in your brain continuously and seamlessly. Okay, so the world is one seamless whole. And if it's not a seamless whole, of course, it becomes confusing. If anyone who's been drunk on a big night out, when the seamlessness kind of fails a bit, you know what that's like. It's a very confusing picture of things and it gets difficult. So it does operate in a very fast, seamless, parallel processing manner. And again, how this is integrated into making you, that's you, and you, of course, are very different to me, is something which is, one of the big questions in science, really, is, what is it and how is it that comes about and what's different, right, about it and why is that? So these are the kinds of questions that, we'd like to understand, in a place like the Brain Institute.